Hello guys, Colin here. Recently I was on a vintage binge and bought a few guitar pedals that are older than me. I got this big Ibanez wah pedal from the 70s and this Proco Rat 2 from 1988. And both of these will get their own videos at some point, but it's the other pedal I bought which I want to talk about today. This blue box of wonder is the DOD Chorus 690. These were made in the late 70s, early 80s, and they're a fantastic vintage chorus. Unfortunately, this one is in dire need of some TLC. As you can see, the enclosure is a bit corroded and there's paint flaking off. There's also a broken switch, and these were mains powered. I need to replace the power cord. I've just opened it up so I can get a little play with the innards, see if I can get it working again. And I thought, hey, why not film this as a video, because it might be quite interesting to see the process of fixing a pedal. Now, I've got absolutely no idea whether this will work at the end of the process. There could be any number of components fried on this board that I don't know about, but at the moment I'm just assuming that we need a new switch, a new power, and make sure it will work with UK mains voltage. I have moved my workspace around to have the workbench in front of me so I can operate on the chorus pedal. I've also got a camera up here as well so you can see some close-ups of what I'm doing. This component here, which I've started to remove, once was a toggle switch to power this device on and off. As you can see, there is no switch part here. It should have originally had a red toggle switch similar to this one here, but it has broken off at some point. I can also see that the bulb and resistor in here are quite badly heat damaged, so that could possibly have been the reason for the entire switch's failure, that these have overheated and broken the red part, or it could just be that it was suffered some physical damage and just so happens that these were also overheating. So this entire switch needs replaced. The back panel for the device has a label that reads no user serviceable parts inside, 110 volts, 50/60 Hz, and 4 watts, which should give me all the information I need to make sure I've got this wired up correctly. Now it's interesting as these are USA made and it's got 110 volts, which is the standard mains voltage in America. However, the mains voltage in the UK is 230 volts. So what would mean that if I was to plug this device straight into the UK mains without any alterations, I would suffer some severe damage to the device. However, the cable that came with the device is this one here, and it has a UK mains plug attached to it, a very old one at that. So at some point, some considerable time ago, someone has taken this pedal and converted it from the stock US cable to a UK one. The big question now is, did they modify the insides of the pedal at the same time to allow it to work with the 230 volts? Or is this the reason that it's lain dormant for so long because they put a UK mains plug on it and fried the insides? We're going to find out. This cable had to be removed anyway as there's some damage to the cable. It's well past its sell-by date, and these type of UK plugs are no longer considered as safe to use by current standards. So this had to come off and get replaced one way or another. So as shown, I'm going to be replacing the original switch with a new red illuminated rocker, which should match what was originally there, and some new mains cable with a modern safety aware plug. This is the interior of the pedal. From the pots here, we can see that there's a code stamped on them. The first three numbers there, 137, relate to the manufacturer of the pot. In this case, that's CTS. And then the next two numbers, 80, would be the year that these pots were manufactured. So this is 1980. So we can date this entire pedal back to then. This is the broken switch over in the corner here, and you can see that I've cut off both the neutral and live from the mains cable, which would have exited a hole up here in the casing. The earth wire was soldered to a tab here, which is riveted to the casing, so that would have kept everything protected and earthed. As mentioned, this pedal was AC powered, however the board components don't work on AC electricity, they work on DC and at a much lower voltage. So this component here is a transformer. It's taking in your 110 volts AC, converting it down to a much smaller value, probably a 9 volts AC, and then the first few components on this board here, these diodes and capacitors, would have been designed to change that AC into DC for the rest of the board to work with. So in reality, there's probably a bit of a likelihood that I could bypass the AC part components here and just wire 9 volts DC straight to the board and do myself away with having to worry about this power switch and this transformer. But I want to try and keep it as vintage accurate as possible and have it run off the mains, so we're going to replace the cable anyway. So the transformer here is an important part of what I need to consider when changing between 110 volts AC and 230 volts AC. How a transformer works is it takes in voltage to the coil on one side, which induces a voltage in the coil on the other side, and depending on the ratio of the windings from the first coil to the second coil depends on how much of a step down or a step up in voltage we're likely to get. Now, if this transformer was only rated to do 110 down to 9, for example, then putting 230 volts into the primary side will mean that we'll get more than 9 volts out of the secondary side, which could damage components on the board, and we need to be very careful not to do that. The primary coil of the transformer is wired to the power switch. That's where the AC voltage is going to come in, and we can see that it's got a green wire and a yellow wire. However, this yellow wire is not original to the transformer. On this bottom corner here we can see it's got some green heat shrink, and that goes to a blue wire which originally did come out of the transformer. So this has been added at some later point. And we can also see that there's a red wire down in here also coming from the transformer which has been cut. This originally would have gone to the switch, and you can see this from a lot of stock photographs of this pedal online. We can also see from the lugs on the power switch that other cables have been sold to this at some point in time and then been snipped off. Now, all of that indicates to me that at the same time as the new UK plug and new cable were wired into the power switch, also someone went ahead and modified this transformer. And of course, the reason that they would have to do that is so that they could get this to work with 230 volts. There are 3 wires in the primary coil of this transformer, and really the only reason to be doing that is to have a tapped coil, meaning that this is probably a 230 or 110 volt transformer, depending on which wires you hook up. There is also no obvious damage to any of the components here on the board, no burnt out resistors or popped capacitors, anything of that sort, nothing obvious and visual anyway. Again, that would indicate that this pedal is probably operated just fine with the old cable attached, and it's only become decommissioned when that switch finally broke. Of course, it makes sense for the manufacturer to originally include a transformer that does both 230 and 110 volts AC. That would mean that you wouldn't have to buy 2 separate transformers for your US models and your European models. You could just put the same transformer in everything and just wire up the different cables depending on where it's going to be shipped to. So going on all of those assumptions, let's just wire up the new power cable and see if I've made a really expensive mistake. I've removed the old switch and left a little bit of each coloured cable on each connection so I can make sure I get the new one wired up in the exact same way. Pop the new switch into the hole. And we come across my first mistake in that the new switch is actually considerably smaller than the old switch. Bastards. For this now, I've wrapped the switch in double-sided adhesive foam, and that's kept it nice and sturdy in the one place until I can get a switch that's the appropriate size and slightly bigger. Oh dear. I'm going to take my new mains cable and decide how much I need to strip off of the outer sheath. I want the earth cable to manage to reach here, and so that's where the hole is. We'll take a little bit further than that, a little bit more than we need. Somewhere around about here. That much will take off. Got to tin all these ends in preparation for soldering them to the switch. I'm going to pass this cable through the hole in the outside. I've got a rubber grommet on here, which is just slightly bigger on the interior than the cable, which makes it move freely. So I need something to strain relieve the cable on the inside. Tying a big knot in the cable ought to do it. We'll strip back the coils from the primary side of the transformer as well. Firstly, I know I want the ground wire from the mains cable to go to this little lug on the chassis here. So we'll just get that soldered on. I've made a slight alteration from the original wiring on the switch. Originally the live came into the central pin, and in the on position that would connect to here, going through the yellow wire, through the transformer, back to the green wire, and then back to the neutral line, creating the full circuit. However, in the off position, we had the live coming in here, then connecting straight to the neutral and back out, creating this loop, which I didn't really like. So the way I've got it wired now, the live comes in here, and it's on state, still goes through the yellow wire, through the transformer, green wire, back to neutral. That's exactly the same as it was. But now, when in the off position, the live goes to absolutely nowhere, which seems much more reasonable to me, and we don't have this power loop just cycling through the switch, which is possibly why the switch burnt out in the first place. So now I've just got a live going to nowhere, open circuit, so nothing can happen. And now we've got the chorus box with its new switch, and that's all wired in. All we need to do is wire the plug on the other side. UK mains plug is actually quite a clever design. You can see that the top pin here, the earth pin, is longer than the live and neutral, and on all sockets there's shutters that close once the earth pin is taken out. So when you put the earth pin in, it opens the shutters to allow access to the live and neutral lines. So it's protection at the plug, and this opens the shutters so that these two can get in. It also means that the earth pin is the first to connect out of all the pins, which is the one that's keeping things safe. Also, you can see that there's insulation at the bottom of both the live and neutral pins, and that means that once the plug has been pulled out a slight way, you can't get your fingers in there and zap yourself. And once you've got to see any of this brass material, these are well disconnected from the power, so you don't have to worry about electrocuting yourself. On the interior of the plug, there is a 13 amp fuse on the live line. Now that's too big a fuse for what I want in this. If this ever draws 13 amps, something's severely wrong, and I want a fuse that will rupture way before that, so I'm going to replace this for a 3 amp fuse. The interior of the plug is clever as well. Each of the wires needs to be cut to a different length to accommodate the different places. The live is the shortest distance and the earth is the longest distance. This means that if the cable ever does get pulled from the plug, the live will disconnect first, and then most likely the earth will stay connected. Again, disconnecting the thing that's dangerous and leaving the safety connection in place. All very clever, and there's a strainer leaf built into the cable as well, so that should never ever happen that it gets pulled out. Now I'm not going to show you how to wire a UK plug. If you want to know how to do that, there are plenty of clever people doing videos on that sort of thing on the internet. I don't need to show you how to do it, you can go and search for those instead. Right, I'm just going to recap my connections. I've got live coming in here. In the on state, that will go through the yellow wire, through the transformer, back through the green, back through the neutral, completing the circuit. That's all good. In the off state, then it will be these two connected, live's going nowhere. So that's fine. I've put a little bit of heat shrink protection on the live lug there, just so it doesn't touch anything and I can't touch it. So that's all good. Earth's connected to the chassis, that's also all good. I'll probably just check with the multimeter that the chassis and the earth pin are connected to make sure that we're all safe here. Everything looks to be good. So we'll get the back panel back on here, screw it into place, and hopefully we will have a working chorus and it doesn't blow itself up. Okay, the moment of truth. I've got the plug plugged into the mains. Power should be going into this device. The switch is in the off position. What happens when we throw that power switch on? Oh hey, look, we've got the illuminated switch come on, which is great, which we knew it would. And now we've got the LED here flashing, and the LED flashes with the speed of the chorus. So hopefully, hold on, there we go. We're set to speed 1, so we can see that the LED is changing rate with speed 1. So we know that works. And then we can select speed 2. And now it should work with that. Perfect. Okay, so we've got a working LED, a working switch, and hopefully a working pedal. We just need to plug it in and see how it sounds. Well, it passes sound and bypass. Let's see what the effect does. Absolutely nothing.
So what we've determined at the moment is that power is getting to the device, it is passing in bypass mode, and the effect light is lighting up, but we're getting no effect when that's on. So there's something else inside here that's not quite right. Now, it could very well take me a while to work out what is wrong with this pedal now, so it looks like I'll have to get back to you when I've got a fix for it. Sorry I didn't get this working in this video, but I'll keep you updated of when I do. Thanks for sticking about, and do remember and subscribe, and that way you'll be able to see when and if I do get this pedal working. I hope I do, because it will be rather fantastic when it does.